So, good morning. Hello, everybody. I think there will be more participants coming later, but we'll start. Thank you for joining today. Welcome to today's fourth organized webinar by Galactica Project. Today dedicated to the topic of product certification and integration in aerospace, especially tackling best practices, barriers, and solutions in aircraft with a special view on textiles. First, let me quickly explain the rules for the webinar. As in the last webinars, please keep yourself muted. Be informed that we are recording this webinar, so also will be uploaded on the Galactica platform. So please, if you don't wish to be identified, edit your details or hide yourself. And the agenda for today, I will start with a brief overview, an introduction to the Galactica project, and after Mr. Manfred Gröning will take over with a around 25 minutes presentation, and we will close the session with a Q&A slot. So please feel free to write any upcoming question on the webinar in the chat, and we will go through it at the end. The Galactica project is a EU-funded InnoSub-1 Horizon 2020 project, and in general, those projects are dedicated to support the improvement of the competitiveness of SMEs. So here, especially, we are aiming to support the creation of new industrial value chains and combining the three sectors of textile, aerospace, and advanced manufacturing. And the concept behind it is that those three sectors that on first view seem to be separated to each other, they have common needs. There's, for example, a lack of digitalization, a lack of use of advanced manufacturing technologies. They are basically unknown to each other. And those SMEs in general in Europe, they are highly specialized. So the vision of Galactica Smart Industry is that we have new overlapping value chains. We are supporting the digitalization. We try to foster the cross-sectoral collaboration among the three sectors and in general exploit a smart industry. For that, 10 European partners built the Galactica consortium. We have 3 clusters in the textile sector, 3 in the aerospace sector, 2 in advanced manufacturing, and on top 2 stakeholders, extra stakeholders in Investor Network, IBAN, and the startup ecosystem, the Science Park Graz as high-tech incubator center. Please feel free to and invited to join us on the website as here mentioned below, and also on social media. As you may know, the webinar is part of a series of 10 webinars. You will find them all on the platform. Also, the past ones are recorded, as I said, this one from today too. And feel free to get informed for the upcoming events and register on the web platform. Yeah, I would like to highly mention that Galactica Project will support SMEs in 2 calls for proposals with a total budget of 2.8 million euros. The first call will start next week with a 1.2 million direct funding. And further in Galactica, there are activities and coaching with a value of 1 million euros planned. For that, for the call for proposals, we use 2 instruments: the Pioneer Acceleration tool as with the focus on concept validation to reach an MVP and validate the business concept. So here, up to 20K per project funding are possible, and single SMEs are eligible. And further, we have the orbital projects with the focus on building demonstrations and make tests and test a functional product in the market. Funding here is up to 100K per project. Requirements are that we have a cross-sectoral partners. In general, we have the criteria to be a UE member state or from the UK. But all those details will be explained in detail on the 24th of March, where we have our matchmaking event planned, and linked to this we have an info day explaining the whole details of the first call for proposals. So please save the date and register already The registration is open on the Galactica platform. And finally, I want to already give you an overview on the next webinar. We have on 23rd of March at 4 p.m. CTA organizes a webinar through the topic of aerospace technologies for the textile sector, tackling automation and digitalization opportunities. For now, I have to thank you for all your participation, and now I want to pass the word to Mr. Manfred Gröning, our invited speaker for today. Mr. Gröning is managing partner and CEO of sales and engineering of the Innovant aircraft interior company since nearly 20 years, and he's holding diploma title of production engineering. With that, I want to invite Mr. Gröning to share with us his screen, and the floor is yours.
Okay, ladies and gentlemen, good morning. Is it visible, the presentation?
Yes, it was. We had it. Yes, like that.
It's now
perfect.
Okay, good. Just need to. It's fine now, right?
Yes.
Okay, good. Yes, good morning, and thank you, Jona Hemmert. Yes, we have this titled Best Practice Barriers and Solutions for Textile in Aircraft Cabin. So we will have a short look on the Innovant portfolio, where you see applications of textiles, and then have a look to the EASA, because the European Aviation Safety Agency is really driving the production, design, and maintenance requirements by law for the industry. And we will have just a glimpse into the structure. Then I picked out the flammability or fire worthiness requirements for aircraft cabins, where, of course, this is very important for textiles to understand. And then a very short look to quality management systems applicable to the aviation industry. Just to give you an idea about Innovant, so we indeed do the whole process from design, engineering design, calculations, pre-processing, mock-ups, prototyping, including testing. You also have to do static tests on the products. Even you need to know your fabric strengths and all these things as well. Then there's a certification process where we cooperating as a production organization with the so-called design organization, according to the EASA definition. That means we do design, but this is formally in a subcontract to the EASA design organization company, who's driving the design data and is responsible for the installation in the aircraft. The other approval is then the 145, which is for maintenance, for the life cycle, or also called to assure the continuous airworthiness. As soon as an aircraft is in operation, all repairs and changes on the aircraft are handled by an organization holding 145 approval, because production is more or less for the new aircraft, and after entry into service, the maintenance organization maintains the aircraft. Again, in combination with the production and the design in the background. Yes, the company was founded more than 40 years ago by my father. It's a family-owned business. We are located in Hamburg, Germany. We have a very broad range of customers, so we are serving more than 180 airlines worldwide. Of course, with a different section of products, but we are in contact with them, and they are our customers. Of course, then you have all the leasing companies, because you need to know that 50% of all new aircraft are owned by leasing companies and managed accordingly. The executive and VIP and jet services interiors is a niche, but also here we are active, and we are in a sense a first-tier company, because we have the direct contracts with Airbus, Boeing, ATR, and also with all the coming and flying regional jets in Japan, China, and Russia. Having a look to the products, just to pick some here, you have the baby bassinet with a fabric cover For example, here you have a child restraint system for the aircraft. Here already you have a combination with foams, fabric, which is also as test standard used for the cushion and rest covers you see on your normal passenger seat. Again, here some covers with cushions. An onboard wheelchair where you have also leather. Of course, leather is also a lot used in the aircraft cabin for seat dress covers and so on. But also imitation leather, so it goes through all different kind of textiles. Here you can see even artwork application made of fabric. This is special because here you're already in the vertical installation on a larger monument in the aircraft where you have again special fireworthiness requirements. So this fabric is then made with, let's say, artificial fibers. I think there's aramid inside in order to pass the fireworthiness requirements. Yeah, just to pick these examples. So you see you have all kind of textiles in interior products. Also here, this is interesting. Here we developed, let's say, for electronic devices, a protective containment bag. Background is that you have heard about that sometimes the batteries can catch fire, and lithium-ion batteries used in laptops, mobile phones, and all these electronic devices, you cannot firefight them with typical methods like with a fire extinguisher. That doesn't work. It will continue to burn. So this bag is made from textiles containing silicate fabrics, and it can withstand up to 1000 degree of heat, while outside then you only measure like 80 degree. So if you have a heat of 1000 degree inside, more or less the outside is just coming to 80 degree. A niche also for fabrics or high-end fabrics, high-end carpets is the VIP section. This is driven by very small quantities, very small production quantities, very individual, quite high-end quality. But also all these materials, if you source them from, you have to assure that they meet the flammability requirements. So there are some small specialized companies working in this field. Imagine you just do a 120 square meter special carpet that it is, and you have to cut in all the let's say all the lines and patterns. So this is quite special and rather niche. Yeah, so I jumped directly to the base because all activities in the aerospace area is driven by the European Union Aviation Safety Agency, EASA. This was founded 2002 and was fully operative 2006. And the objectives here are really to keep the safety level, to have uniform standards throughout all the member states. Of course, preparing and nearly executing the legislation. It's a very direct legislation process. So this is ruled by the Commission. So the national parliaments of EU member states don't have to, or they even can't discuss this or release this in their own parliament. This is really executive from the Commission and immediately active as a law. And of course, the one task is then to monitor that all these regulations are followed. And this is supported by the national aviation authorities of each member country. And they mainly take care on the monitoring of the production organizations and the maintenance organization. The so-called design organization is monitored and handled by EASA directly. Yeah, and all certifications for aeronautical products is ruled here. So these are the aircraft, the engines, and parts and appliances. So behind parts and appliances, this is what you have seen from the Innovant product portfolio. So it's ancillary equipment, it's parts and appliances. It's not an engine, it's not a propeller, it's not a fire extinguisher, because for these kind of materials, you also have like standard technical orders. But all this is guided and managed, and of course then to overview and guide all the development, manufacture, and maintenance of aeronautical products. There's of course a lot of more items where or objectives you can follow then to the EASA homepage. Of course, they also manage all the issues like operating aircraft and even down to issues like airport management. So you can look deeper into that. There are also associated members like Switzerland, Norway, so we end up in 31 member states. And okay, Great Britain is no more member of the EASA. For Great Britain, that means, as far as I know today, that they do their certification processes locally with the National Aviation Authority. And if they want to obtain an European approval, they have to hand in all this once already checked certification program again to the EASA to get an European approval. I did not mention here other big aviation authorities, but of course, the Federal Aviation Administration in the United States, let's say, is the second large block regulating the aerospace industry. And of course, EASA and FAA are trying to harmonize the regulations so that you work on the same requirements, although there are differences. Approval overview in EASA. So you have the EU regulation, of course, and all these numbers, and they are already a couple of times amended. But the so-called Annex 1 of the base EU regulation 748/2012 is called the Part 21, and the Part 21 has several sub-chapters or subparts. One of them is, for example, the 21J, which is applicable to the design organization. And the other, for example, is the 21G for the production organization. So you have to have an organization which can show you have the right organization form, you have the procedures in place, and also the competences, because competence is important. You cannot obtain a design organization approval without showing really down to the CV of each member of the design team what the qualifications are in order to obtain a scope, because you would always apply for a certain scope of certification. For example, I would apply for having the design organization approval for cabin interiors, but not for, let's say, avionics or landing gear or whatever. So all these organizations have to demonstrate compliance with the regulations, which really details what you have to do, what you have to fulfill, and what you have to perform, and your, let's say, responsibilities, but also your privileges. In the end, you are working as production organization or design organization on behalf of the authorities. So in the moment you release a product to service or release a new product to a new aircraft, this confirmation is on behalf of EASA to declare airworthiness. So let's say you design a product, then the main task of the design organization is to approve all these design data and to check for compliance with all the applicable regulations, which are laid down, for example, for large aeroplanes in the so-called certification specifications. So the closing point for the design organization is to check, is the installation of this part possible in this aircraft? It's really one-to-one specific. So if we are, let's say, in a retrofit, we're changing an aircraft, then the design organization really has to prove and to show that if you install, let's say, a baby bassinet to a wall in the cabin, very simply said, the goal is to say, if I install this part, baby bassinet, to this partition in the aircraft, then the partition remains a partition with all its performance values, and the baby bassinet remains baby bassinet, but you can install, so they don't interfere in this installation or with the surrounding of the cabin. So this is, let's say, one of the major tasks of the design organization to assure that the aircraft remains aircraft and the part is well integrated. Of course, there are many more certification specifications. You have this for small aircraft, we have this for engines, for propellers, for balloons, and so on. So also the general aviation, and such a certification specification. If you follow the CS25 for large aeroplanes, this is your book how to build an aircraft. So at least you have to comply with all the applicable paragraphs in this regulation. So what I think is good to highlight, because we are talking about textiles, is to look for the specific fireworthiness requirements. Oh yes, first here another link. All these regulations, it's quite complicated. If you're not in this subject, it's not so easy to tackle. But I think these publications, the so-called easy access rules, they're all changes and all this evolving regulations are kept together, updated. And the good thing is you have the, let's say, the regulating paragraph, then you get some guidance material, and then also you get some acceptable means of compliance, means an accepted interpretation of what is the rule requiring and what I have to do. So these books can be downloaded on the EASA homepage and are very helpful to understand, let's say, the basic regulation of the whole framework, legislation framework. And then you have these like part 21 and so on and so on. So these are very useful documentations. Of course, it's very dry stuff. It's all law. And of course, you need some experience to make your right interpretations. Yes, and in this certifying specification 25, we find a paragraph 853, which is describing what are the fireworthiness requirements, what has to be met, and it's really specific that always here we are looking to the combination in a final product. So of course we can apply a test to the single fabric, but of course very often fabric is combined with foam or with any backing, or it's on a honeycomb sandwich panel on walls. And you need sometimes glue to apply. And so the testing is always a combined testing. This paragraph has an appendix F, which describes then all the test methods. And here you see the FAA comes in. So there's a policy statement of the Federal Aviation Administration. This can be understood also as a kind of acceptable means of compliance, because they also give rule for comparison, because sometimes it's really annoying in the aerospace industry that you have to test again and again and again and again, but it's always the same material. So here are some open doors for accepted comparison, for a comparison basis that you can rely on already performed test data, and so that you don't have to test again. But everything which is not described in this policy note, you cannot create a new kind of comparison base. So this would always be discussed in the panels of the FAA. And then there's also very interesting, the so-called Aircraft Materials Fire Test Handbook. That is a living document. It's updated chapter by chapter. And there really all details are in, even all the test apparatus are described, all the procedures you have to follow during testing, the conditioning of the test specimens, the size of the test specimens, approval of test specimens. So it's also a very comprehensive handbook for this topic. I'll give you the link later. So what we're talking here, we have basically 4 categories. We start with the flammability. From industrial point of view, non-aerospace, this is more or less the category which is called B1, B2. So they're not fully comparable, but it's a Bunsen burner test for with vertical flame application to the test specimen. Then the smoke density is a big issue because evacuation of an aircraft with a lot of smoke makes the evacuation very difficult. So there were a lot of efforts to reduce the smoke density. And then you have a so-called heat release test, which is, I think, the most severe test. And this is a test where more or less you are putting the flame on the test specimen to measure the kinetic energy this specimen is sending back while it's under fire. And for all these seat cushions and dress covers combinations, there's a so-called oil burner test, which is also a quite strong test. And because the mass of cushions and dress covers in an aircraft is, of course, high, so there's a special test procedure to show compliance. So that means even all raw material, let's say simple fabric, have at least to meet this section A materials. So they must pass the test criteria, and this is the base even for all the raw materials. So you check your raw material to perform on these paragraph A, which does not mean that you combine it with other materials and then pass again the test. So this is always the tricky issue in the combination. Just a little overview. Here you have the 60 seconds vertical Bunsen burner test. And you see this is for ceiling panels, wall panels, partitions, galleys, floorings, means also non-textile flooring or textile carpet flooring, and storage compartments. And here the 12-second test is the same. You see here explicitly mentioned textiles. So means if you have a blanket in the aircraft, just the blanket for traveling, then this blanket would meet these 12 seconds vertical test. And also just the cushion itself also needs to meet that. But if you do a full passenger seat cushion, again, you have to do then later the oil burner test. So in selecting materials, we always check if the raw material already has good properties itself, single. And then, of course, you need to go for the combined testing to make sure it's working. This is, of course, experience-based, but if you have new materials, new technology, it's very recommended to, in the very beginning, to make confident tests to assure that you can pass the requirements. Because in the end, when you do not pass the fire tests, your product will not be approved. And so in some products, even if you combine unusual materials together or have new materials you have no experience with, it's a very important milestone or key point to assure that is working. Just one more here. There's also a horizontal test. Here you see it's like for these window panes from the inside, not the outside window. Placards, signs, little plastic parts illuminated, and some elastomerics and seat belts, because seat belts are made of nylon webbing, and this material will not pass the vertical test. So you have a horizontal test and some more, but I don't go into detail here. So it's for wiring and all kind of cargo compartments. Again, a different story, but we stay in the cabin. So as mentioned, the combined test is really the crucial test. And also it must be really, the best way is really to take it out of the product to make your samples cutting from the product or from the panel you configured maybe. If this is not possible, for example, when you change an aircraft, you cannot cut out all the parts from the existing furnitures, but you can maybe have the technical background on the combination of the materials and then make a simulation of a cut section so that you rebuild the specimen without destroying the actual part. But it must be as installed. Yes, then we come to the heat release test. Here you see this applies when you have more than 20 passengers in an aircraft cabin. Then you need to also fulfill heat release for, let's say, large cabinets. So all the ceiling panels, so all these big surfaces you see in the aircraft have to meet the heat release test. And in combination, when you are in this section for heat release, you also have to do the smoke density testing. The threshold is that if a product is larger than 2 square feet, which is approximately the format of the paper format A3. So if you're larger than this, then you have to perform the heat release. Means for very smaller parts, you can stay with the 60 or 12 seconds vertical Bunsen burner test. But if you are larger than format A3, you have to go for this test. And in my view, this is the most severe test on materials. So I think, for example, a wool fabric with 5% polyamide will not pass heat release. So you cannot use this fabric, a wool fabric, for vertical partitions or walls. If this will not be working, it's working then again with combinations of maybe artificial fibers, aramid or other things, and then you may pass this heat release test. Then this so-called oil burner test. So there's a very specific guidance how to prepare the test specimen, which volume is represented from all kind of materials you use in. A basic build-up would be you have the foam core, maybe also 2 different foams with different density. Then for sure you need a kind of fire blocker layer. So these are thinner textiles who really can block fire. That means protect the foam, because foam, of course, burns quite nice. And then you have the dress cover outside. There are also a lot of details. What are the pass criteria? For example, one pass criteria is that when you apply this large flame, I think it's like for 3 minutes or something, then, for example, the weight of the test specimen, so the specimen must not have lost more than 10% of its weight. So if you have a burn through the dress cover and then the flame is penetrating the foam, then of course you lose weight, and 10%, for example, is here the pass criteria. And for some dress cover materials, it's also not easy to meet, or your scope or your range of material selection for seat covers or seat cushions is therefore also quite limited. You cannot use everything. So leather is already the edge, and then with wool fabrics you pass quite well. And of course, with the artificial fibers, you can also achieve quite good results. Yeah, so these are basically the 4 main fire properties which have to be performed as tests, depending on the type of product and where it's installed in the aircraft. And size is, of course, always a question. As mentioned, you can find more information here in the Aircraft Materials Fire Test Handbook. You can download it chapter by chapter. I think there's no full book downloadable, but you can download all the single sections. Yeah, okay. One point I did not mention, because it's not really a full airbusiness legislation issue, is the emission of toxic gases, so toxicity. But OEMs like Boeing or Airbus would also ask always for the toxicity issue. Although if you use a material, mostly there are some polycarbonates, for example, who have I think it's always in the chloride area, that one value is not mostly not met. But here there is a chance also to waive the toxicity requirement with the OEM, because toxicity is so far not implemented into the regulation. But somehow, if you want the utmost of your product, you should also consider the toxicity issue. Good. So I think all these fire worthiness for textiles very a key factor. Otherwise, you cannot place these materials in the supply chain, or you cannot really raise value in the chain by doing this. And also, of course, you have to think where to position. If you just supply like the raw material, then of course you're not that fully involved in the value of the supply chain, because then the production organization configures the product and the design organization approves it. So so strategically, you really have to decide, okay, I stay on the technology side, on the manufacturing side of fabrics as a raw material, or you enter really into the aerospace business, but this way would mean at least to become a production organization according to EASA Part 21. And another issue is you need to be on a kind of product level, not on the raw material level, because EASA says also we will not grant production approval to companies producing raw materials or even standard parts like rivets, screws, nuts, bolts, as long as these are based on the international standard like NAS or DIN, so accepted international standard norms. So this also is important to know. You cannot apply if you only produce your raw materials. So a carpet manufacturer cannot become a production organization. But if you configure the carpet, if you cut it to size, if you have all the engineering drawings and the installation with the design organization, and you have your drawing set, and you configure the carpet, you do your, or I don't know, ketteln, I don't know the English word, so you protect the edges from the cutting, and then you have a product. So and with that somehow you can work in the production organization level because you have fully approved, designed, documented carpets, for example.
Sorry, Mr. Gröning.
Yes.
For interrupting. I don't know if you finished. I know there's one more slide. Yeah.
This is the last slide. I kept it very, very short. Everybody should be aware that the aerospace industry quality management system is based on the EN 9100, which follows the 9001, but has all these extra elements which are important in the aerospace industry. Then you have to organize your quality management handbook, because for us, we have 3 standards to fulfill, and we were lucky that we were able to keep it in one book with some cross-references to the aerospace Part 21 and 145 issues. And if you go for this design organization, which is also a quite tough way, but then it's recommended to have it in a separate book, because the design organization approval does not really mean your typical design engineering work you do in your organization, which is covered under 9001 design engineering. So here, as I mentioned in the beginning, it's more or less the take care about the right installation. And last but not least, of course, as you know, some big OEMs then come also with the extra quality requirements, which are quite individual, and sometimes also above what the EASA regulation is asking for, because you always need also to keep in mind that what the EASA is putting as a base is the minimum technical standard. And of course, you can go above, and some manufacturers like Airbus or Boeing, they want to go above and then, of course, require these more severe testing or whatever from their suppliers. Yeah, I hope this gave you a first impression for those who are not in the aerospace industry, just to have a point of entry to see barriers. Others who are in the aerospace industry are quite aware about this, and also how much work it is to, in the end, to become a production organization or even a design organization. Yes, thank you.
Thank you very much, Mr. Gröning. I already checked here. We have some questions, and the last question from Claudio Otto, I can already answer that. Yes, the presentation summary will be available on Galactica's platform, as all the other webinars too. You can see and have a look on it again, and take your time to resume the whole presentation. I also saw that you had some other questions, and I would like to pass them to our speaker. We have the first question: what do you exactly mean when you refer to textiles in the monuments? I think you've been speaking about the monuments in the cabin interior.
Yes, right. So one example was, for example, this decorative panel we made for one airline, where you have a fabric with, I don't know exactly, but I think it's aramid fibers, because when you are in the vertical installation on the wall, the heat release requirement will apply. And so it's very tough. So you can only meet that with this kind of fabric. And so as soon you bring fabric on monuments in a vertical position on large monuments, you have to do all the tests I mentioned, except of course for the oil burner test that is only for the seats. But yes, so this is meant as soon you go into the vertical, if you cover walls or whatever, you have to fulfill all the tests I mentioned. You don't, if you just do like the basket for our baby bassinet, then for this fabric, the 12 seconds vertical Bunsen burner test is fine, because it's only the fabric with some zippers applied to a metal structure. So there you are easy. But as soon you go to a vertical on monument, you have to fulfill all the tests. Which you can say, which will not be working with all materials who were living before, like cattle and sheep and so on. So all nature fibers will not pass the heat release.
I think this also more or less answers the next question. What about high temperature resistant textiles versus resistance of embedding matrix?
Embedding matrix?
Maybe Claudio Votto, you can specify your question again. Well, and then there was another question, comments on referring to the utilization of leather in the interiors, leather as material.
Yeah, leather is of course, it's of course very often selected for business class areas, for the seats, for the dress covers. You can pass the oil burner test with leather, that's no problem. Leather also meets, if you treat it well, also the smoke emission and the toxicity. Depends a bit on the thickness of the leather and the quality of the leather, because it's a natural product. You have to keep an eye on your production quality for the leather. But of course, it's a lot of use, but it's more in the more exclusive areas, and of course, for maintaining the leather covers you have to exchange them, I think, more often than fabric, because as soon you have some fluids on the leather, they can smell and they can get ugly and so on. So I think you have to take more care on leather surfaces. But there's also the trend to have like artificial leather, looking like leather. I think there's one renowned manufacturer in Great Britain. The product is called E-leather. So this is an artificial mix of leather elements and artificial things. And for example, this material also pass heat release. So that means with this material, you can again make decorative elements on walls. Yeah, so you can cover it by walls, or you stitch like patterns into the leather and have some foam backing that you get this fluffy walls, let's say. But this is already quite challenging to have this leather look with some foam backing and then the sewing of patterns. So this is technically very interesting, I think, also for the sewing process. But these are, let's say, elements you can find in airlines like Qatar Airways or Emirates, who much like this leather look and even do the pattern on the leather with the sewing and have some foam backing. But this is already challenging to find out, again, about all the material combination, because you have glue as well, the glue inside. So if I would start such a program, I would always, in the very beginning, check out the combination and see if I can pass the requirements. Because otherwise, if you commit to supply and in the end your test doesn't work, it's big trouble.
Thank you. And yeah, back to the question before. I think the question is like, yeah, comparing temperature resistant textiles versus the resistance of composite materials. But,
yeah. Yes. So the composites, so let's say all the walls or galleys, partitions, stowages are made of honeycomb sandwich panels, which are phenolic on a phenolic resin base and fiberglass layers. This is a typical setup, and this kind of honeycomb composite are performing very well on the fire properties values. So, for example, if you take a bare panel of composite material like 20 millimeters thickness, because thickness is always also an issue in testing, yeah. So the thickness, of course, influence the results. But here you have always a good base. So I know that you can do a lot of combinations, adding on material to composite walls. You have some, let's say, space. Yeah. So let's say the panel itself maybe give you a value of 20 for heat release. Yeah. Let's say 20. So 65 is the highest you can. So you still have enough gap to see what happened if I put now glue and fabric on top. So this is a good starting point. But of course, if you look to all these rigid furnishings in an aircraft, you are always confronted with this phenolic honeycomb panels.
right. I think this was the last question. Yes, there's no other questions in the chat. So yes, at this point, I'd like to thank you, Mr. Gröning, for joining us today and follow this invitation from Galactica. And I'd like to finish this session, just give you another, I don't know if you can see it again. Share this screen. No, it's not working. Well, I wanted to share again the outview on the next webinar. But so just feel welcome like this for the next webinar. It's on the 24th. Oh, sorry, 23rd. And we will tackle, what was the topic? I will have a look on it again. Next webinar will be about aerospace technologies for the textile sector in general, but focusing on automation and digitalization opportunities. And then I also want to remind you again to have a look on the platform, and especially for the matchmaking day on the 24th, where we'll have the info day for the first call for proposal. So yeah, thank you very much, everybody joining the webinar, and particularly Mr. Gröning for this useful information. Yes, I look forward to see you all in the future Galactica activities. Thank you all. Wants to, if somebody wants to stay and has another personal question, maybe you can stay.
Yeah, I stay for a while, and also if you have the handout and you have more questions, you can always contact me. But I will stay a while if someone has some more questions.
Hello, good morning, everyone. My name is Chetan, and I have joined the meeting from Spain. So my